In this video today, we're going to do coordinate proofs with different methods. So by the end of today, you're going to be able to see I can determine the type of quadrilateral represented with coordinate points and justify it by using different methods. So we're going to talk a lot today about the term proof, okay? So I'm assuming most of y'all have played the game Uno, right? So there are three postulates when we talk about Uno that we accept as universal truths in that game. So you play the same color card, right? Or you play the same number symbol card, or you play a wild card to change the color, right? So we're going to do this. So first you're given a yellow card, and then you have these other cards in your hand: a red 4, a blue draw 2, a blue skip, a green skip, and a green 4. And we're going to prove that you get a blue draw 2 at the end, okay? So what we want to do is we're going to talk about how we got from our first card, the yellow 4, to the blue draw 2, okay? So obviously the first card we were given, right? Okay. So then how do we get a green 4 if we had a yellow 4? So isn't this the same number? It is. So that's how we go from the first card to the second card. Now how would we go from a green 4 to a green skip? Yep, these are the same color, right? Then how do we go from a green skip to a blue skip? These are the same symbol, right? Okay, and then how do we go from a blue skip to a blue draw 2? These again are the same color. Now, we had a statement on the left as to why we did what we did, what card we drew, right? And then we had a reason for that, pulling that card on the right. Now, I want to see if you guys can do this with this statement right here in your hand. So on this one, it says you draw a blue 9. So obviously we're going to put the blue 9 here. And then you have these cards in your hand, right? And then you're going to prove that you have a red 2 at the end. So the red 2 is going to be right there. So let's see if you guys can go ahead and do this just like we did the one before. Come back to me when you're done. So obviously the blue 9 was given. Now let's see if we have any other cards that are either 9 or a blue, right? So it looks to me like we have a blue plus 2. So we're going to put the blue plus 2 here, so that's because it's the same color, right? Okay, then it looks to me like the only other card that I could go with is the green plus 2, right? Green plus 2. Now, why can we do this? Because it's the same symbol, right? Okay. Then we got a green plus 2, and what can we do next? There we go, green 6, right? So we got a green 6 because it's the same color again. Okay, so we cross out that one. What do we have next? Ooh, red 6. Do y'all see that? A red 6. Again, that's because it's the same number. Okay, and then why could we go to a red 2? Same color, right? This is the way that a proof works. We make a statement on the left. We are doing some steps over here, and the reasons we could do these steps are over there on the right, okay? So that's kind of what I modeled to you, kind of an example of something like a proof. It's not a proof, but it's similar. So first of all, we have a paragraph proof. That's the claim, evidence, reasoning. In a paragraph proof, the factual statements are written in paragraph form. That's your blank. That's a paragraph form, right? So we're just going to write factual statements, right? And we're going to put some reasons for those factual statements, right? Then at the end of the paragraph, we're going to have a conclusion, and it's reached, and its mathematical concept is proven true. Then we also have the two-column proof. A two-column proof has numbered statements and corresponding reasons that show an argument in a logical order. So a two-column proof, the true statements are placed in the first column, which is the column on the left, and the reasons why the statement is true are placed in the second column. That's the column on the right, okay? We're going to use these today. So first of all, this first one, example 1, says determine if the following coordinates create a square, rectangle, or neither. Okay, so we're going to actually draw these lines AB, BC, CD, and AD. Okay, so there's a couple ways we could prove this. We're going to do one way with the paragraph proof, and then we're going to do a different way with the two-column proof, okay? So what I want to do is I want to talk about sides. Don't we know that all 4 sides are equal with a square, right? And also with a square, don't we know all four angles are right angles? Now, that's not going to be the statement that we need to, that we're actually going to prove. We're going to prove that all four sides are, and I'm just going to put the symbol perpendicular, okay? All four sides are perpendicular. That's what we're actually going to prove, okay? Because if I have right angles, I have perpendicular sides, okay? So all four sides are equal, so let's look at that. So I'm going to go up 1 here, over 1, 2, 3. Okay, and I'm going to do this opposite side right here. That's 1 up and 3 over as well, isn't it? Okay, so let's look at sides BC and AD now, okay, or AD and BC. So this one, notice we go 3 down, right, and 1 over, right? Okay, again, over here we're going 1 over and 3 down. Do y'all see that? So do you notice that all the numbers are the same? 1 and 3, 1 and 3, 1 and 3. We have a -3, yeah, and this was a -3 over here too, right? But it doesn't really matter because we're going to square those numbers, okay? So what we're going to do is we're going to look at all of these sides, and I'm going to do 3 squared plus 1 squared. That's going to be the square root of 10, right? And isn't that true of all of our sides? AB is equal to BC is equal to CD is equal to DA, right? Does everybody see that? Okay. Now, let's talk about the claim that all four angles are right, which would mean that all four sides are perpendicular. Perpendicular sides would mean they have negative reciprocal slopes, right? So let's look at the slope of AB. We went 1 up and 3 over, right? 1 up and 3 over, okay? And notice also DC is equal to that too, right? So that's DC. So we're start talking slopes right now, right? Okay. Now let's talk about the sides BC and AD. So let's talk about AD. What's the slope of AD? Actually, let's change colors here. I'm going to change it to green. AD, what's its slope? AD slope is 3 down, 1 over, right? So this is going to be -3 over 1. And isn't that also equal to what? BC, right? Okay, so then what does that mean? So let's talk again. This one was 1/3 and 1/3. This one was -3 and -3 because it's -3 over 1, right? Okay, so can you tell that consecutive sides are perpendicular, right? All four sides are perpendicular. So let's go ahead and write that statement. So that means AB is perpendicular to BC, is perpendicular to CD, is perpendicular to DA. And those are really the only two statements I need with the sides to prove that this is a square, right? So that therefore we can say that ABCD is a square because of steps 1 and 2, right? Got it? Okay. Then down here, we're going to use a different approach when we talk about this one. We're going to talk about the diagonals, okay? So I'm going to erase our rise and runs over here because we're now going to talk about the you know what, I'll just erase the whole thing and we'll do it over. I'm just going to draw this one in black. So A, B, C, D, and then back to A, right? Okay, so we're going to talk about the diagonals now. We're going to talk about AC right here. So let's talk about AC first. So what I want to say is I want to say that the diagonals are, we're going to see if the diagonals are congruent, okay? So we're going to say AC is 1, 2 down, 1, 2, 3, 4, right? So AC is equal to, we said 2 down and 4 over, right? So that's going to be the square root of 2 squared plus the square root of -4 squared. So that's going to be 4 plus 16. That's going to be the square root of 20. See that? Okay, so now we want to see if dB is the same, right? So is dB the same? So once again, we're talking 1, 2, 3, 4, 1, 2. Same numbers, right, y'all? So aren't those going to be, so this was 2 and this was 4, right? So that's also going to be the square root of 20. So AC is the same length as BD, isn't it? So we could say that BD is equal to AC. Now we said it there, right? So why? Because the diagonals are equal. Okay? Now, we're also going to talk about the diagonals being perpendicular because that's the other thing, right? So now we got to look at the slopes. So let's look at the slope of AC. So when we look at the slope of AC, we're going down 2 over 4. So what is that equal to, y'all? Negative 1/2, right? And then we're going to look at the slope of BD. BD, what's that slope? Let's look up here. BD was 4 up, 2 over, right? So that's going to be 4 divided by 2, which is 2. So what does that tell us about these slopes and these segments? That means AC is perpendicular to BD, right? So the diagonals, I should have said S up there, are perpendicular. Okay? So what does that mean? That means we can say this is a square. Why? Because of steps. Well, let's go ahead and count this. 1, 2, 3, 4, right? 1, 2, 3, 4. Because of steps 2 and 3. Okay? Oh, we could say, actually, you know what, let's say it like we said it before. A, B, C, D. So we'll say A, B, C, D is a square. Again, because of steps 2 and 3. Okay? So now let's look at this next one. It says determine if the following coordinates create a square or rectangle, or neither. Okay? So let's plot them. 1, 1 is A. 5, 3 is B. 4, 5 is C. And what is that? I can't even see that. 0, 3 is D. Okay, so A to B, B to C, C to D, D to A, right? Okay. I didn't draw that line very straight over there, but let's see if we can fix it. Because my point was right there, wasn't it? B was 5, 3. Right there, right? And there. There we go. Kind of looks like a rectangle, doesn't it? So how could we prove that this is a rectangle? Again, we could prove that it has 4 right angles, and we could prove that opposite sides are congruent, right? So don't we do both of those with slope? Okay, so let's talk about 4 perpendicular sides, right? Consecutive sides are perpendicular, right? Okay, so we could also say consecutive. Consecutive sides are perpendicular, okay? So what does that mean? So let's look at A, B. So this one is rising, right? So that's going up 1, 2, and over 1, 2, 3, 4, right? So the slope of AB is equal to, let's check this one, 1, 2, again, see that? And 1, 2, 3, 4. So that's also 2 over 4. So AB we say is going to be parallel, right? Parallel to DC, and both of those slopes are 2 up, 4 over, which is equal to 1/2. So let's now talk about AD or DA and CB. Okay, DA, 1, 2 down, and 1 over, right? 2 down, 1 over. So DA is equal to 2 down, 1 over. Isn't that negative 2? Okay, over here as well. We're going 1, start here 1, 2 down, right? 1 over. So there we go again. So DA is going to be, DA is parallel to CB, right? So what can we say then about all the sides, though? They're all perpendicular, right? So I'm just going to write that here. AB is perpendicular to BC, is perpendicular to CD, is perpendicular to DA, right? That's what we want to talk about, okay? Then, that's really all we need to prove that this is a rectangle, right? 4 right angles, right, y'all? So that could be all we're done, and we're done, okay? Or I'm going to do a different one down here. We're going to talk about the diagonals, okay? So we're going to talk about these diagonals. They should be the same length, right? So let's look at AC. So let's say the claim, diagonals equal, right? That's our claim. Now, either one of these can prove it, okay? So diagonals are equal. So let's look at AC. AC, let's count up. 1, 2, 3, 4. 4 up. 1, 2, 3 over. So this is equal to 4 squared plus 3 squared, right? That's going to be the square root of 16 plus 9. That's 25. So this one is 5, okay? And now let's look at, do this one in black. DB, right there. Okay. Oh, that's just a straight line. Let's just count it. 1, 2, 3, 4, 5. Check that out. So that means DB was also equal to 5. So AC is equal to DB, right? So that was enough as well to prove this. So we could say ABCD is a rectangle, right? And we could either state because of step 1 or step, in this case, 3, because we wrote it in a different thing, right? Either one of those would have been enough, okay? That's all you needed. All right, so let's see if you can do this one. What is the most precise classification for this one? Pause the video, come back to me when you're done. So this one is J, -2, 1. Right there is J. Then we got K at 2, 2. Then we got L at 1, -2. And then we got N at -3, -3. Okay, so let's see if we can figure out what this shape is. I can't draw straight lines today, y'all. Sorry. So J to L. So, oh my goodness. I'm going to give up in a minute. This was -2, 1, and that was where? 2, 2, right there. So straight line. Try it. There you go. Straight line. Straight line, straight line. Okay, let's talk about what we see. Okay, so I propose it's either parallelogram or it's a rhombus. So let's just look at the side lengths, okay? And then we're going to talk about the other way. So we go 1 up, 1, 2, 3, 4 over. 4 down, 1 over, right? Or in this case, actually 4 up, 1 over again. This one, 1, 2, 3, 4, 1 over, right? This one's 1, 1, 2, 3, 4 again. So what do you notice? So we could say JK is equal to KL is equal to LN. That's supposed to be an L, y'all. LN. Having trouble today. LN, which is equal to NJ. And all of those are equal to the square root of 1 squared plus 4 squared, right? So isn't that going to be the square root of 5? Indeed. That's enough to prove this is a rhombus, right? What is the one other thing we could have done to prove it was a rhombus? Compare the diagonals, right? Okay. So what is the NK? What is the slope of that one? 1, 2, 3, 4, 5. NK is 5 over 1, 2, 3, 4, 5. 5 over 5. 5 over 5 is 1, right, y'all? 5 over 5 equals 1. So what should the slope of NL be? Or sorry, is that NL? No. JL. What should the slope of this one be? If indeed, sorry, can't draw a straight line today for nothing. If that's it. So let's count. 1, 2, 3. We know that's falling, right? So JL is -3 over 1, 2, 3 over 3. So that's -1. So what can we say about NK is perpendicular to JL, right? So either one of those steps was enough, okay? So you could write either one you wanted down here in this statement. And what was the reason again? So what were we trying to prove? We were trying to prove here that all four sides were equal. Here we were trying to prove the diagonals are congruent, or perpendicular, sorry. So I'm just going to say NK is perpendicular to JL and Y, because NK slopes, so we're going to talk about slopes again, remember. So slopes of NK was equal to 1, and of JL was equal to -1, right? So they're negative reciprocals of each other, right? So the diagonals, I can't spell today either. Diagonals are perpendicular. Okay, that's enough to prove that this is a rhombus, okay? Or we could have said all four sides are equal, right? Either one.